Predictive modeling represents a paradigm shift in contemporary marketing, transforming reactive operations into proactive enterprises. The historical context of data in decision-making typically positioned organizations as retrospective analysts, focusing on what has occurred rather than what will occur. The emergence of advanced deep learning algorithms and computational architecture enables the reinterpretation of data not as static artifacts, but as signals from which actionable insights may be continuously extracted. Central to this predictive revolution is the aggregation of granular interaction data. Modern consumers interact with brands at numerous digital touchpoints, websites, apps, social channels. Each click, scroll, or hesitancy provides microsignals that, although individually subtle, collectively foreshadow transitions in the consumer journey. Deep learning models ingest and synthesize these data points to infer latent patterns, allowing marketers to detect a progression from passive discovery to active purchase intent far before a transaction is logged. The adoption of Bayesian inference as a modeling framework imbues these predictions with adaptability. Unlike traditional frequentist models, constrained by static training data and fixed assumptions, the Bayesian approach facilitates continual model recalibration. This adaptability is crucial within markets characterized by volatility and rapidly shifting consumer preferences. New behavioral evidence instantly informs updated predictive probabilities, allowing organizations to dynamically adjust their outreach strategies as user intent evolves, mitigating the risk of misaligned messaging or lost engagement. This real-time forecasting finds its business rationale through precision resource allocation, operationalized via propensity scoring. By quantifying the likelihood of specific user actions on a scale from 0 to 1, marketers can segment audiences with clinical accuracy. High-propensity users, those almost certain to convert without external stimulus, represent low ROI targets for additional spend. The emphasis, then, shifts to this swing population, individuals in whom tailored messaging or incentives can tip the scales. This targeted allocation maximizes marketing yield, directly linking predictive analytics to bottom-line outcomes and elevating data science as an executive decision lever. However, the efficacy of predictive systems is inherently bounded by the quality of their underlying data. Compromised data, partial profiles, duplicated entries, or automated noise degrades model validity, resulting in what is known as hallucinated demand, spurious insights that skew strategic initiatives. Thus, robust data governance and hygiene protocols become not ancillary, but core operational imperatives for future-ready organizations. Strategic architects must advocate for continuous cleansing, validation, and enrichment of data repositories to preserve model integrity. Looking towards the horizon, the integration of predictive analytics with automation heralds a new era in customer journey orchestration. Automated self-optimizing funnels, capable of autonomously constructing and iterating campaigns via ongoing analytical feedback, promise to reduce human intervention to oversight and strategic governance. This evolution challenges leaders not simply to deploy predictive models, but to align their operational logic with ethical standards and long-term financial goals, ensuring machines optimize both for immediate outcomes and sustainable growth. In summary, predictive modeling is less about guessing the future and more about architecting it carefully, in real time, through an unbroken loop of observation, inference, and adaptation.